So, hello everyone. So, we are going to discuss question number 35. This is a part of your, you can say, the previous question because under a one question, we have to solve three parts of it, and this is one of them. We have to find here the value of variance of t. Okay, so in last video number 34, I have already shown you like how directly you are going to find the value of this variance of t, right? But what if you have no information about the formula for variance of this distribution? Where like we found in the previous question that t follows gamma distribution with the parameter n comma 1. Usually we learn according to the ISS, alpha comma lambda are the parameters, right? Because in the book Gupta and Kapoor they have given lambda comma alpha, but your UPSC ask alpha comma lambda. So according to this, there is a different PDF that we have to use. Okay, and I give all the information in my live classes. These are the paid batches. If you have any query, any doubt, you can ask me. Okay, so everyone, in the previous video I will put the link in I button, or either you will find it at the end of this video. So t follows your gamma distribution with parameter n comma 1, right? And we have to find the value of variance of t. So now you know what is the formula for variance of t. So for variance of t, the formula that we have to use is expectation of x square minus expectation of x whole square, right? So that means we have to now calculate the value of expectation of x square for gamma distribution. So first of all, we are going to write down the PDF of gamma distribution. So we have to write lambda to the power alpha upon gamma alpha e to the power minus lambda x and x to the power alpha minus 1. Here I have taken the random variable x, but in the question we are denoting it with t. So later you can replace this t with this x. Okay, so just to show you, I'm just taking x. Okay, now if I want to find out the value, and also you can see instead of t I have taken x square, you can also put expectation of t square minus expectation of this t. So I will later I will replace this x with this t. Okay, so I have closed it here inside a bracket. Now everyone, if like I'm going to do all the calculation using x, and at the end I will, if needed, I will replace this x with t. Okay, so finding the value of expectation of x square, now this is very easy. Integral 0 to infinity x square lambda to the power alpha upon gamma alpha e to the power minus lambda x x to the power alpha minus 1 and d of x. Now everyone, I am just going to take out some of the constant values outside. So what I can write, lambda to the power alpha gamma alpha integral 0 to infinity, we have lambda e to the power minus lambda x, and x to the power I can write here alpha plus 2 and minus 1, because you can see here we have the same base, so we can add the powers. And I have written it in a form like that. Why I have written it like that? Because I am going to use the gamma integral. So if like I have discussed about gamma integral in the previous video as well. Okay, so if you are watching this video, so I am expecting that you know about the gamma integral, but if you have no information, then why are you waiting for? Please join our live classes and you will get every basic detail there. Okay, so this is your lambda to the power alpha upon gamma alpha, and here using gamma integral, this is the value, let me highlight it, this is the value of a and this is the value of n. Okay, this is the value of n and this is the value of a. So what we are going to write using gamma integral, this is representing whole gamma integral. So using it, what we can write, we can write gamma n, right? So at the place of n, what I can write this alpha plus 2 and a to the power n. The value of a is lambda and a to the power n is alpha plus 2. So I can just break it, I'm just breaking it down. So I am writing it in a form like that so that I can cancel out this from this. Okay everyone, so now you can see what we have 1 upon lambda square. Now we have gamma, see gamma alpha plus 2 also, like it can be written in a form like alpha plus 1 whole upon, this is your gamma alpha. So that why I have written it like that, so that we can take out this value out of the gamma. Okay, this is a property that you must have like learned in your basic classes. So what I am going to write next, 1 upon lambda square, and it can be written as alpha plus 1 and gamma alpha plus 1 whole upon gamma alpha. Like if I'm going to show you, gamma alpha plus 1 can be written as alpha gamma alpha. Okay, so now 1 upon lambda square into this is alpha plus 1 already. Here I can write alpha, gamma, alpha. In the denominator, I have gamma, alpha. I can cancel out this and this. And what I have now? I have now alpha times alpha plus 1 whole upon lambda square. So this is the value of your expectation of x square. And we already know the value of expectation of x, which was your alpha upon lambda. Okay. So now everyone, we got this value for general PDF, right? But right now, according to our question, you can see what is the value of alpha and lambda. This is your n and 1. So that means we have to replace these values, right, at the place of alpha and lambda. So what we will get? Okay, so first of all, let me rub it so that we can have a space here. Okay, so everyone, now you can see what I can write. What I can write, expectation of x is now n, and what is the value of expectation of x square? It is now at the place of alpha we have n plus 1. In the denominator at the place of lambda we have 1, so we have n plus 1 now, right? So this is the value. Okay, now after that everyone, we have to find the value of variance. So variance of t, substituting these values, I can write n, I'm going to multiply it. This will become n square plus n. Okay, then minus n square, cancelling out this and this, and now you can see variance of t coming n, right? And you can see everyone in which option it is, this answer is given. It is given in the option number D. Okay, so D is your final answer. I hope you all like this solution. If you have any difficulty, you can ask me on Instagram, you can ask me on WhatsApp, you can also comment below. Okay, as soon as I will see your message or comment, I will definitely give you a reply. So thank you everyone for watching this video. Have a nice day.